Hello everyone, Paul here, and I am not nearly as in the woods as you might think. I am here at a suburban park in southern Charlotte called Big Rocks Preserve. And of course, whenever a geoscientist sees the word big rocks on a map, we can't help but check it out. And sure enough, there's some interesting stuff out here. So the point today, there's a couple points, but one of them is to understand that you don't need to go to some big fancy place like the Grand Canyon or Arches National Park to see some geology. It's all around. It's everywhere. And so let's take a look and see what's out here. All right, I'll be right back. Okay, so the lighting is a little bit funny, but if I come over here, I think we can see better. There we go. Big rocks, and there's a guy over there climbing them. And yeah, so oddly enough, our Big Rocks Park has some big rocks in it. So let's check something in particular out over here that I want to show you if I can walk without tripping. And here we go. So here we go. So this is not two rocks on either side of a tree. Well, it is, but this is a tree that grew up between two rocks and literally split them apart. There's a number of things in nature that do this. Ice will also do this, and it is an important component of physical weathering. You have, biological materials breaking rocks into pieces. If you get some water in there and it freezes, if you've ever accidentally left a water bottle in the freezer overnight, you know that there's a pretty good bit of force there as that water expands when it turns solid, and that happens in nature too, in particularly colder areas where you'll get what's called frost wedging, where the water in the rock will freeze and literally break it apart. Now the problem here is that this rock gets graffitied on a lot and so the color is really not something you want to pay attention to, but let's go see if we can find some fresher rock to have a little bit closer look at and see if we can figure some stuff out here. So this is just a few yards down the trail. And when I show you this, the first thing you notice is that hole there behind my walking stick. I'm using the walking stick to mark something I want to show you here in just a second. But you can see there's a pretty substantial hole in the rock there. If I come over here, you can see a pretty substantial hole there too, along with some black paint covering some graffiti. But those are natural. That's just an area where the rock was not quite as hard or well indurated, a little more susceptible to weathering, and so you get these holes weathered out of the rock. So what is this rock? That's really interesting. Like I said, the paint over the rock makes it a little difficult to tell, and I don't know how well. Oh, this is showing up pretty well. If I look at this surface, it's very rough, but if I look right here, I can see a mineral that has pretty good cleavage. That's a feldspar. And then we can see some other things. We can see some mineral crystals. It's been really, really chewed away, though. But as we look at it and we look at, fresher, well, there are no fresh areas, right? I would desperately love to pull out my rock here and break off a piece of this, but no. So anyway, I have no collecting permit. I'm in a park, a protected area. Let's not do that. But anyway, it's very, very rough, very, very irregular, but with some pretty large mineral grains sticking out of it, okay? So this is a granite, or something like a granite, but it is nothing like the granites that we see in the lab, or if this is a distance learning, that you see in the pictures. And this points to the difference between looking at rocks in a lab and looking at rocks in the field. In the field, they've been weathered, and this one has been very heavily chemically weathered. Excuse me. Over there, when we saw the tree, we saw a good example of physical weathering that physically breaks down the rock. Here we see a great example of chemical weathering, where that surface is just chewed up. Now, if I was to break off a piece of this, the inside would look a lot more like the granite that you're used to seeing in lab, but we're not going to do that. One of the first things y'all just have to learn is how to identify rocks, in the field, the way they actually look in the field. And this is frequently what granite looks like in the field. So if you do go into geology, you're going to have to get used to this kind of thing, where the exterior of the rock has been heavily, chemically weathered, and that's why we carry around hammers. In areas that aren't archaeological sites that are protected, we'll break off a piece of it and look at the inside of it, not the outside. Okay, I'm gonna walk a little bit more, and then we'll talk a little bit more. So hey everyone, so we know it's a granite. That's good. But, when we're doing field geology, the name of the rock is rarely the point. I mean, sometimes it might be, but usually not. What we're usually more interested in is, what happened, right? How did it get to be here? And so there's some options, right? This could be something like the Stone Mountain granite outside of Atlanta, in a little town named, oddly enough, Stone Mountain. That granite formed when Pangea came together, and we generated a lot of heat and pressure deep down, made some magma that never breached the ground surface or became a volcano. It just cooled and then was later exposed. That Pangea coming together happened about, I think I said it, but about 300 or so million years ago. Maybe, there's ancient volcanoes to the east of us. Look at my Morro Mountain field trip for that. Maybe this is part of that ancient 5 to 600 million year old volcanic mountain range over there, and maybe this is part of that. Maybe this is some magma that once again just never breached the surface to become a volcano, because remember, it's granite, it's coarse grained, it cooled underground. This was not lava. This was a body of rock that cooled underground and then was later exposed. Or maybe it's something like the White Mountain granite up in New England. That's about 100 million years old. That formed when New England ran over a hot spot that is oddly enough called the New England hot spot. And so, there's a number of geologic settings where we can do this. And so, which one is this? Yeah, I don't know. I don't know. There's been a lot of work out here on the archaeology. This site has been occupied by humans for as long as there have been humans in this part of North America. It was a meeting site. It's been used for all sorts of things. It's a very important archaeological site. That's why it's a park. But I have not as yet found any information on the geology of these rocks. When I look at the description of the rocks in this area, it does not mention granite. So I don't know. So here's our job for today. Here's what I want you to do. I want you to ask yourself, okay, how would I approach this problem? And I want you to think of it in two different ways. The first way is, let's say you're a geologist and you have a lab and you have friends with labs and you have resources and whatnot, and you're the first person or the first geologist to come on this. What's the first thing you'd want to know? What's the first, once you figure out it's a granite, what's next? What's the first thing you want to know? And maybe maybe a little bit of research into what kind of equipment you might need to figure that out. It's not something you can put in your pocket, I promise. And then the second way I'd like you to think about this is the way you are right now. Like something that you could do like from where you are to maybe get a little bit more information on this. And this isn't going to involve, looking around on Google until you find something. I'm thinking maybe a little bit different than that. You might need to Google up a few things, but don't just Google around until you get something. Figure out a way to access some more reliable, let's say, information, and tell me what you would do. So write that up. I don't know. Write up should be 2 paragraphs, probably not more than a page. Seriously, not more than a page. And tell me, what you would do as a geoscientist, approaching this from the point of view of the first person to work this, but then also what you would do just as who you are right now if you wanted to learn a little bit more about this, and Google was turning up nothing, which it probably will turn up nothing. So anyway, think about it a little bit, write it up, and stick it in the Dropbox. Okay, all right, y'all have fun. Bye bye.